Okay, so Dalton had the concept that there are atoms, which are individual particles that can never be divided. But in fact, we know that this is not true, right? That that atoms can actually be divided into different pieces, right? And they found this, the first time that they found this was with J.J. Thomson, right? And J.J. Thomson had what he called a cathode ray, right? Where he took a cathode, right, which is a positive and a negative electrode, and he charged these with energy. And what they ended up doing was they emitted a ray of electrons, right, in a vacuum tube, right? It emits this kind of glow, right? And this is actually the technology that they used in the first televisions, right? That they shone a cathode ray with this glow through an image, and as a result, you see an image on your television screen. But what he used it for was to generate a ray of electrons, right? And he took this ray of electrons out of this tube, and he's shown it through a charged plate, right? And the charged plate had a negative end and a positive end, right? And as you can imagine, from an array of negative tubes, from an array of negative electrons, right, they'll be repelled by the negative plate and attracted to the positive plate. And then they show up on a phosphorescent scale, right? And what this phosphorescent scale does is it shows you how far it's been deflected, how far this ray of electrons has been deflected. And what he ended up doing was he found the mass per charge ratio of a single electron, right? And he varied the electric field strength, and he found the right electric field strength to deflect an electron by a certain amount. And this enabled him to figure out basically the charge, the mass per charge ratio of each electron. And he found essentially that there was a subatomic particle with a mass of 1/2000th the mass of a hydrogen atom. Okay, so this very, very, very low weight substance with a very high charge. And as a result, he came up with what he called the plum pudding model, right? Which essentially stipulated that there's a positive charge spread throughout the atom, right? And this positive charge is not in particles, right? It's just a positive charge that's spread evenly throughout throughout the entire atom as follows, right? A ball of positive charge with negative electrons that are interspersed inside of it. Okay, evenly distributed as if it were a plum pudding with random chunks of these plums inside of it. We likened it to this kind of plum pudding, right? Where it's got positive charge, this white part, and it's spread throughout, and then it's interspersed with electrons, right? These little plum pieces. Okay, and it was up until other chemists to disprove this and show that there is in fact a positive particle, right? Not just a positive charge spread throughout the entire atom.